Okay, so what I need you all to do is go and grab your journal because starting today and moving forward in the class, we are incorporating a new journal structure in the class using the left-hand side and the right-hand side. The left-hand side will be all teacher-guided notes, definition, teacher-led problems, and on the right-hand side is any problems that we want you to work out. So when we check your journals, the left-hand side will show us how well you can take notes, and the right-hand side will tell us how well you understand what you're doing. So go ahead and label your journal today, Understanding Rational Numbers at the top. And I also want you to write today's objective, which describes what we are learning today. So in today's lesson, we are going to define rational numbers and then use that to add and subtract fractions. So go ahead and take a moment to copy this down in your journal on the left-hand side. All right, so copying this down on the left-hand side, a rational number is any number that can be made by dividing two integers. So pretty much a rational number is any number that is a fraction or can be represented as a fraction. So an example is 1/2, 3/4, 409 over 20. What else? 6/9. There's plenty of different ways to represent fractions, and any number that can be represented as a fraction is a rational number. Now, let's think of the example 0.5. Can we write 0.5 as a fraction? Yes, 1/2. So that means that 1/2 or 0.5 is also a fraction. There are certain decimals that are rational numbers. Not every decimal can be, but if you can take a decimal and convert it to a fraction, then that means you're good to go. It is a rational number. So you don't need to copy this down in your journal, but just listen as I explain. Any number that can be turned into a fraction using two integers is considered rational. So I use the example of 1/2 and 3/4, but -1/2 and -3/4 are also rational numbers because at the end of the day, even though they're negative, they still can be written as a fraction. So this is what I mentioned before. Decimals can also be rational numbers as long as we can convert them into fractions. So let's go ahead and try to add these fractions together, right? So we have, we got 3/4, and then we have 1/4. And this is just kind of recapping how to add fractions. In order to add or subtract fractions, we need to have the same denominator, okay? If we don't, then we got to make it that way. But in this particular case, we do have the same denominator. So what's going to happen is our denominator stays the same, and then we add the two numbers on top. So 3 plus 1 is 4, and our answer is 4/4. Now let's go ahead and try the next problem. So we have 6/7 minus 2/3. Now the problem that we have here is that our denominators are not the same, so we cannot subtract them. So what that means is that we need to find a common denominator. Now, what is the denominator that we can have in common? We need to find factors of 7 and 3. So, or multiples of 7 and 3. So we have 7, 14, 21, 28. And then for 3, we have 3, 6, 9, 12, 15, 18, 21. Okay, so here's one that they have in common, right? So I'm going to make my denominators 21 for both fractions. How do I go from 7 to 21? What do I have to do? I have to multiply by 3. So whatever I do to the bottom, I also got to do to the top. 6 times 3 will give me 18. Perfect. Now, next one. How do I go from 3 to 21? What do I multiply that by? I'm going to multiply that by 7. So whatever I do to the bottom, I also got to do to the top. 2 times 7 will give me 14. So now I have common denominators, and now I can subtract them. So 18 minus 14 is 4, and 21 minus 21, and then the denominator stays the same. So we keep that 4/21. This should be written on the left-hand side of your journal. Alright, so now let's try to do these problems. These are a little bit more tricky. So in this particular case, we have mixed numbers. So that means that we need to convert them to improper fractions. How do we do that? Well, we do that through a process called MAD. The first thing that we do is we multiply these two numbers. Then we add the two numbers that we get. And finally, we keep the denominator the same. Okay, so let's do this example. I'm going to multiply 7 times 2. 7 times 2 will give me 14. Then I'm going to add 14 to the 1. 14 plus 1 gives me 15. And I keep my denominator the same, so my denominator is going to stay 2. Let's try the next one. 3 times 3 will give me 9. And then 9 plus 2 will give me 11. And I keep my denominator the same, so this is going to stay as 3. Okay? Now, in order to add them, we need to find a common denominator. So I'm going to try finding common denominators of 2 and 3. So we got 2, 4, 6, 8, 10, 12, etc. Then I have 3, 6, 9, 12. Oh, I already see one that I could use. Now, there's two that I could use. I could use 12. But I could also use a simpler one of 6, right? So I'm going to use something more basic like 6. How do I go from 2 to 6? What do I need to multiply by? Times 3. So I'm going to do the same thing to 15. 15 times 3 gives me 45. Now I'm going to do the same thing to 30 to the fraction with the denominator of 3. How do I go from 3 to 6? Got to multiply it by 2. So I'm going to do the same thing to the top. 11 times 2 is 22. Now I can easily add them. I'm going to keep my denominator as 6. And then 45 plus 22 will give me 67. So my new fraction will be 67 over 6. Alright, so let's go ahead and try these. Now these are definitely more difficult. I want you to write numbers 1 and 4 on the left-hand side, but you're going to do the rest, numbers 2 to 3 and 5 to 6, you're going to write those on the right-hand side because I'm going to have you try those on your own. Okay? Now, number 1, now we're going back to those rules where we have a positive and a negative number. What was the rule when we have a positive and a negative number? What we actually do is subtract and then you keep the sign of the one with the greater absolute value. So whichever one has the greater absolute value, that's the one we're keeping a sign of. So let's look at this one, right? These have two different signs, so I'm going to subtract. I keep the denominator the same, because in this case the denominator is the same. And then I look at the numerator. I subtract 7 minus 5, and that gives me 2. And then I think which one has a greater absolute value. Now, if they have the same denominator, then all we have to do is look at the numerator, right? Which is a bigger number, 5 or 7? 7, right? So and 7 is negative. So my answer is also going to be negative, all right? Do the same thing with numbers 2 and 3. Find that common denominator and then use your integer rules. Now let's go down to number 4. What we're going to do with subtraction is the keep, change method. So I'm going to keep the 3 over the 7. I'm going to change that subtraction to a plus. And then I'm going to change this 10 over 7 to a negative 10 over 7, right? And now we're going back to the rules that we use in this problem. We're going to keep that denominator of 7. We're going to subtract 10 minus 3 also gives me 7. And then I'm going to keep the sign of the one with the greater absolute value. Since they have the same denominator, I'm going to look at the negative 10 and the 10 and the 3. 10 is a bigger number and it's negative, so my answer is also going to be negative. 7 over 7 can be, negative 7 over 7 can be simplified as negative 1. So make sure you always simplify your fractions. Go ahead and try 5 and 6 in your journal. When you are done, raise your hand and your iPrep facilitators will check your work. I want you to also go ahead and try solving this problem on the right-hand side of your journal. So set up an equation or an expression that'll help you figure out how much water did your dog drink from the bowl. So I said it was 3/4 fill, and then after drinking, it was now 2/8 fill. So how much did they drink? Figure out how you can find out what that remaining amount is.